Anduril's Thunder introduces a new vision for autonomous attack aviation. Developed in partnership with Archer Aviation, Thunder is a next-generation Group 5 autonomous tiltrotor designed to operate alongside crewed helicopters in highly contested environments. Its vertical takeoff and landing capability allows it to deploy without a runway, while its tiltrotor configuration provides the speed, range, and efficiency of a fixed-wing aircraft. A hybrid electric propulsion system and optimum speed rotors are intended to improve endurance, reduce mechanical stress, and lower the aircraft's acoustic signature. Thunder was designed from the outset without a cockpit. This frees internal space for sensors, mission systems, and interchangeable payload modules. Depending on the mission, the aircraft can carry up to 10 Hellfire, JAG-M or Barracuda 100M missiles, 16 Altius 600 air-launched effects, or as many as 76 70mm rockets. A separate forward module can accommodate up to 12 counter-drone effectors. The platform can also be configured for armed reconnaissance, electronic warfare, maritime patrol, contested logistics, or as an autonomous mothership for smaller unmanned systems. At the heart of Thunder is Anduril's Lattice Mission Autonomy software. It enables the aircraft to interpret high-level commands, navigate, avoid obstacles, manage formations, and coordinate missions with minimal operator input, even when GPS or communications are disrupted. Anduril says 3 Thunder aircraft operating with a single AH-64 Apache could significantly increase the formation's precision strike capacity while keeping aircrews farther from enemy defenses. Displayed at FIA 2026, Thunder represents a shift toward distributed, autonomous combat formations, built to deliver greater reach, survivability, and affordable combat mass.
Well, my name is Frank Lazzara. I'm the Director of Sales and Strategy for the MV-75 program, the mock-up of the aircraft you see behind us. In our booth this year, we are featuring everything under the Textron parent company organization. I work for Bell, formerly known as Bell Helicopter, but we are Bell Textron. And so around the booth you will see not only the MV-75, which is sort of our premier, our feature right now, but also a lot of other Textron products that you'll see around the world in the commercial side of aviation. The MV-75 is the next generation operational tilt rotor that we designed to be purpose-built for the U.S. Army's utility, medium lift utility mission, their air assault mission, what the Black Hawk helicopter does now. We are currently under contract for weapon system design. We are building, delivering parts, and starting to build the first 6 prototypes. And then we'll also build 2 limited use test aircraft for the first 8 aircraft delivered to the U.S. Army under that contract. The holy grail of vertical lift flying or helicopter flying has always been, how do we go faster, farther? It's finding a way to make an aircraft do both. Can it do all the things a helicopter can do, hover and fly like a helicopter and give you that runway independent access for things, but also transition to fly on a wing, which is a much more efficient way to fly further and faster. And we did that with the V-22. It's been a very successful operational tilt rotor, and this is the next generation, taking advantage of all the things we've done in tilt rotor since XV3 through the experience of V-22. So one of the key features that you're talking about is it's now a fixed engine nacelle. On the V-22, that whole nacelle moved and the engine inside of it moved. For numerous reasons, we wanted to design a fixed engine nacelle. One of them was because the Army has been doing air assault through the side entry and exit of helicopters since the Vietnam War. So we were trying to design an aircraft that we could take advantage of side entry and exit. In order to do that, we had to move the nacelle out of the way. Most importantly, it reduces a lot of complexity. And we learned through time and experience with the V-22 that it would be ideal to reduce the complexity of that setup, reduce the density of the nacelle itself. What's put into the nacelle makes it easier for maintenance, which was the key driver in this program, because the Army needs to be able to maintain their aircraft in the field. It can't be too complex to do that. So now, instead of the whole nacelle moving, we just have the prop rotor gearbox that moves. And for example, if you ever have to do an engine change or a gearbox change, on this aircraft you can make those changes when necessary without having to do as much maintenance. The easy way to say that is it's going to go twice as fast and twice as far as a Black Hawk. It'll actually do a little bit better than that. And we'll see where the final design lands as far as, performance goes. Usually there's discovery and test. Models tend to be conservative, so usually you get more performance when you actually start flying the aircraft, but we'll see where that goes. The average Black Hawk's probably planning its missions in the 110 knots ground speed range, maybe even 120. For this aircraft, you'd be more like in the 220 to 250 knots range for your planning. And then you can go, as far as the combat radius and combat range go, easy to say it'll go at least twice as far as the Black Hawk goes. When it's in what you would call helicopter mode or conversion mode, it feels just like a helicopter. So, the pilot has to sort of master two skills, but it's really not any more difficult than learning how to fly any other aircraft or new technology. And it's a digital fly-by-wire aircraft, so it's actually a very pilot-friendly aircraft. There's a lot of opportunity to reduce pilot workload during missions. You have flight control computers who do an awful lot for you when it comes to managing the configuration of the aircraft to make sure you're in a good aerodynamic state, for example. And, well, right now we're working as hard as we can to deliver aircraft as fast as we can. It's a pretty dynamic schedule. We have to stay aligned with the budgeting requirements, and we're working to stay aligned with the Army on that. Right now we have, I think, up to 3 prototypes that are in some stage of assembly in production, and we look forward to delivering those aircraft, or at least the first aircraft, sometime late next year, or maybe early the year after. But I would say that's pretty dynamic right now.
Thank you so much.
Beta Defense's MV-250 is a new hybrid electric vertical takeoff and landing aircraft designed for autonomous military logistics and multi-mission operations. Built to support dispersed forces in contested environments, the MV-250 can operate without conventional runways, delivering cargo, equipment, and critical support directly to austere forward locations. The aircraft combines helicopter-like vertical lift with the range and efficiency of fixed-wing flight. With a payload of 2,000 pounds, or 907 kilograms, it can conduct missions beyond 250 nautical miles. Carrying a lighter 1,000-pound payload, its operational radius increases to more than 750 nautical miles, while surveillance and ferry missions could exceed 1,300 nautical miles. The MV-250 can also remain airborne for up to 12 hours at an altitude of 20,000 feet, supporting persistent intelligence, surveillance, communications, and command and control missions. At the core of the platform is a 1.3 megawatt turbo generator. More than 1 megawatt of electrical power can reportedly remain available for onboard mission systems, including advanced sensors, electronic warfare equipment, counter-drone technologies, and communications relays. After landing, the aircraft could also supply electricity directly to forward operating bases, allowing it to function as both a transport platform and a mobile power generator. Its modular cabin provides around 250 cubic feet of space and can accommodate 3 joint modular intermodal containers. The aircraft can be rapidly reconfigured for cargo transport, casualty evacuation, ISR, electronic warfare, launched effects, or counter-uncrewed aircraft missions. Displayed at FIA 2026, the MV-250 highlights the growing role of autonomous hybrid-powered aircraft in future military logistics, offering extended range, lower crew exposure, and greater operational flexibility for dispersed forces.
I'm Bob Gibbs with Textron Aviation, and I lead the sales effort for our defense and special missions customers. I'm here in front of our Cessna Skycourier, which is our newest product, actually, from a clean sheet design. And it's a product that actually is very focused on bringing light tactical lift to the militaries of the world. And it is designed for rugged use, it's designed for easy use, and it's designed for very light maintenance footprint and very high dispatch reliability. When you compare it to others, that's how Belgium made their decision. It's about the low life cycle cost, the high reliability of the aircraft for frequent use and use in austere environments. The aircraft was designed as a very rugged aircraft that's designed to be operated without support. It's able to go somewhere and come back without having to have any ground support where it's going. Maintenance is very simple in the aircraft. The pre-flight, post-flight is also very automated, very simple. It's a pilot walk-around. Everything can be seen from the ground, or it will be identified in the cockpit. That allows a quick turn anywhere in austere environments or any environment without support. The structural design, there's a large sponson beam that runs across from one landing gear to the other. Fixed landing gear, no complexity, no hydraulic system. The only hydraulics in the aircraft are the brakes. The flight controls are all redundant. Large control surfaces, large flaps. We've actually worked with Garmin, and we have a multifunction display, which is high def video capable, but it also goes beyond that. We actually can drive mission computers from the bezels in the cockpit. So you could actually have the right seat, or the co-pilot, being your mission operator. That allows a lot of flexibility in roll-on, roll-off technology, because if you're going high-end surveillance, you can have dedicated consoles and whatnot in the back, but the same aircraft, you can roll those off, and you can still carry some sensors, some intel gathering equipment, and have that operated by the flight crew. Aluminum structure, so very repairable, twin engine, Pratt & Whitney PT6 powered, Macaulay aluminum propellers, everything designed to be rugged, robust, and reliable. As far as the configuration inside, we've designed a completely modular aircraft. When you go in and look at it, there's seat tracks. We have 6 different seat tracks run full length. Any seat, and the loading is the same all throughout the floor. So any pallet, box, or seat can be anywhere in the aircraft. What we're doing with the jump seats, for example, so we're going to have the side-facing seats for mission use. And in that configuration, again, you can have just the aft section or just the forward section or the full section. So you could have some traditional seats and some mission seats, or you could have some mission seats and the air medical configuration. It's all modular and all being designed as plug-and-play modular flexible installation. We actually have our first military sale was before Belgium. They won't allow us to tell about it. But we have actually had a lot of interest in military transportation, multi-use for military and tactical transportation. We have hard points on the wings already certified. If the structure's there, it's certified, done. We have extra fuel available in the aircraft, all of that to give you a tactical advantage for the warfighter.
BAE Systems and Lockheed Martin are advancing Blizzard, a missile-shaped, uncrewed aircraft designed for electronic warfare and attack missions in contested airspace. Unveiled at the Farnborough International Airshow in July 2026, the roughly 181-kilogram system is being developed by BAE Systems, Falcon Works, and Lockheed Martin's Skunk Works. Blizzard is intended for deployment from crewed or uncrewed aircraft, including platforms such as the Eurofighter Typhoon and F-35. Studies are also examining the release of multiple vehicles from transport aircraft, such as the A400M, while future concepts could include ground and maritime launch options. Captive carry and release trials have already taken place, and a full flight test is planned. The developers aim to make the system ready for production by the end of 2027. Blizzard is primarily designed to operate close to hostile radars and surface-to-air missile systems, where it could jam, deceive, or expose enemy air defenses while keeping crewed aircraft farther from danger. Its rocket engine is expected to provide a range of several hundred kilometers, although final performance details have not been released. The vehicle is designed around modular payloads, allowing it to support different missions without requiring a completely new airframe. Future versions could coordinate autonomously in groups, receive updated instructions during flight, and operate in areas where satellite navigation is disrupted. Possible missions also include counter-drone operations and support for suppression of enemy air defenses. Blizzard remains under development, and key details such as payload configuration, recovery method, production cost, and operational entry date have not yet been confirmed.
One of the most significant innovations unveiled at the Farnborough International Airshow 2026 comes from European missile manufacturer MBDA. As battlefields become increasingly saturated with low-cost drones, the company has introduced a new mobile air defense system designed to defeat mass drone attacks without relying on expensive high-end missiles. The new system combines MBDA's Countermass Interceptor, or CMI, with the surface-launched ASRAAM missile on a highly mobile Supercat tactical vehicle. This layered approach allows operators to use the lower-cost CMI against drones, while reserving the more capable ASRAAM for high-speed threats such as combat aircraft, helicopters, and cruise missiles. The concept significantly improves magazine depth, reduces interception costs, and provides commanders with greater flexibility in modern air defense operations. Purpose-built for counter-drone missions, the Countermass Interceptor is designed to destroy Class 1, 2, and 3 unmanned aerial vehicles, using an infrared seeker that enables autonomous fire-and-forget engagements. The missile can be cued by radar or electro-optical sensors and is also capable of operating in a passive mode, reducing its electromagnetic signature in contested environments. In terms of performance, the CMI weighs 53 kilograms, measures 2.3 meters in length, and is powered by a 122mm solid propellant rocket motor. It can engage aerial threats at ranges and altitudes exceeding 6 kilometers, while providing 360-degree day and night coverage. The missile uses canard flight controls and a blast fragmentation warhead to neutralize incoming targets. Beyond the Supercat vehicle, MBDA says the interceptor can also be integrated onto tactical vehicles, containerized launchers, and even unmanned surface vessels, making it a highly adaptable solution. Integrated into MBDA's Skywarden counter-UAS architecture, the new system represents a major step toward more affordable, mobile, and layered air defense capable of countering both mass drone swarms and more sophisticated aerial threats.
One of the standout innovations at the Farnborough International Airshow 2026 is Leonardo's Proteus, developed for the Royal Navy following its successful maiden autonomous flight in January 2026. Proteus represents a major leap toward the future of uncrewed naval aviation. Displayed after its historic maiden flight earlier this year, Proteus is designed to operate without a pilot on board, using advanced artificial intelligence, autonomous flight software, and onboard sensors to carry out complex missions with minimal human intervention. Its appearance at Farnborough also marked confirmation that the program has been extended through at least mid-2027, reflecting continued confidence from the UK Ministry of Defence in the platform's development. Unlike conventional drones that require continuous remote piloting, Proteus is autonomous by design. Mission operators simply assign a task, while the aircraft independently plans its route, avoids obstacles, navigates to the objective, and completes the mission using a high-integrity flight control system and an advanced autonomy core. The aircraft is intended to operate alongside crewed helicopters as part of a future hybrid air wing, reducing the risk to personnel during dangerous missions. Proteus is a 3-ton class vertical takeoff and landing aircraft with a payload capacity exceeding 1 ton, giving it the flexibility to carry sonar buoys, surveillance sensors, electronic warfare equipment, cargo, or other mission-specific payloads. Its large modular mission bay can accommodate up to 2 standard NATO pallets, allowing rapid reconfiguration for different operational roles. Designed primarily for maritime operations, Proteus is expected to conduct anti-submarine warfare, intelligence, surveillance and reconnaissance, sea patrol, logistics resupply, and underwater vessel tracking. Developed under a £60 million program for the Royal Navy, Leonardo Proteus represents a major leap toward fully autonomous military rotorcraft and highlights how artificial intelligence is transforming the next generation of naval aviation. The Global Combat Air Program, or GCAP, the ambitious 6th-generation fighter project jointly developed by the United Kingdom, Italy, and Japan, is more than just a new stealth fighter. GCAP represents one of the world's most advanced multinational defense programs, bringing together the industrial and technological strengths of 3 leading aerospace nations. At Farnborough, the program received a major boost after the 3 governments confirmed a £4.6 billion funding package, securing the completion of the concept and assessment phase and reaffirming their commitment to fielding the aircraft by 2035. The announcement effectively ended speculation about the program's future and highlighted the strong political and industrial alignment behind the project. Designed by the Edgewing joint venture, the future combat aircraft will feature advanced stealth characteristics, artificial intelligence, and highly integrated sensor fusion. Supporting the aircraft is the GCAP Electronics Evolution Consortium, formed by Leonardo, Mitsubishi Electric, and ELT Group, which is developing next-generation radar, electronic warfare, and secure communication systems to provide superior battlefield awareness. Powering the aircraft will be a new generation engine developed jointly by Rolls-Royce, IAI Corporation, and Avio Aero. More than 100 subscale engine tests have already been completed, paving the way for full-scale demonstrators. Meanwhile, defense companies MBDA UK, MBDA Italia, Mitsubishi, Heavy Industries, and Mitsubishi Electric are collaborating to integrate advanced future weapons into the platform. Another milestone announced at Farnborough was Canada joining GCAP as the program's first official observer nation, opening the door for potential future international cooperation. Scheduled to enter service from 2035, is expected to become one of the world's most capable 6th-generation fighter aircraft, combining stealth, advanced networking, artificial intelligence, and next-generation propulsion into a single combat platform designed for the battle space of the future. One of the standout advanced air mobility platforms at the Farnborough International Airshow 2026 was the eVTOL developed by Eve Air Mobility, an Embraer-backed company advancing the future of electric flight. Displayed as a full-scale mock-up alongside an immersive flight simulator, the aircraft showcased the program's progress from concept to active flight testing, following its first successful flight in late 2025. The exhibit highlighted Eve's focus on certification and commercial readiness, supported by Embraer's decades of aerospace experience. Designed for urban and regional air mobility, the all-electric aircraft combines vertical takeoff and landing capability with the efficiency of wing-borne cruise flight. Its lift plus cruise configuration uses dedicated vertical lift propellers and rear pusher propellers, delivering quieter operations, improved efficiency, and simplified maintenance. The aircraft is designed to carry 1 pilot and 4 passengers, making it suitable for short-range passenger transport between airports, city centers, and regional destinations. Beyond its aerodynamic design, Eve is developing an entire advanced air mobility ecosystem, including air traffic management software, digital services, and global maintenance support to ensure safe and efficient eVTOL operations. The company has already completed dozens of flight tests and is preparing for transition flight evaluations, with production of certification-conforming prototypes scheduled to begin later this year. Displayed at FIA 2026, Eve's eVTOL demonstrated that the future of electric aviation is moving beyond vision and into real-world testing. Backed by Embraer, it represents one of the industry's most mature programs, bringing quiet, sustainable, and efficient urban air mobility a significant step closer to commercial reality. The Airbus U-145, a helicopter-sized autonomous aircraft developed for demanding military and civil missions. Derived from the proven H-145 helicopter family, the U-145 combines the payload capacity, endurance, and reliability of a twin-engine rotorcraft with fully autonomous flight capability. Unlike the crewed H-145, the U-145 removes the cockpit entirely. This creates additional internal space for cargo and mission equipment while eliminating the need to expose pilots to dangerous operating environments. With a maximum takeoff weight of 3,800 kilograms, the aircraft is designed for heavy payload missions, including autonomous logistics resupply, casualty evacuation, surveillance, armed reconnaissance and disaster response. A dedicated nose loading door, foldable loading table, and reinforced cargo floor allow supplies and equipment to be loaded rapidly, even from austere or dispersed operating locations. The U-145 is also being developed as a modular, mission-agnostic platform. Operators could integrate sensors, communications equipment, or specialized payloads depending on operational requirements. One of its most advanced proposed roles is that of an airborne drone mothership. In this configuration, the U-145 could deploy smaller air-launched systems for reconnaissance, electronic warfare, or precision strike missions. Its autonomous architecture is expected to combine onboard sensors, advanced computing, and artificial intelligence, enabling independent flight and mission execution with minimal human control. Powered by two Safran Ariel 2E engines, the platform also benefits from the H-145 family's established reliability, low operating costs, and relatively low acoustic signature. Selected for our top 10 FIA 2026, the Airbus U-145 represents a major step toward heavy autonomous rotorcraft capable of supporting logistics, reconnaissance, and crewed-uncrewed operations without putting aircrews at risk.